Greetings to all professor and friends. My name is Akrapul Chittapon. Today I will give a short lecture about artificial heart valve. Outline of today will cover the introduction that talk about what is a valve, anatomy of the heart, and who need artificial heart valve, followed by the history and timeline, then the type of artificial heart valve. Let's begin what it is to a valve. Valve is an object that medically used for stop, control, and regulate the flow of pressure or of a fluid substance like water or gases. By using a ball, disc, and slit to block the pathway of the fluid movement, this could be controlled by the manually or either automatically by using the mechanic property of the valve materials and or the pressure that occur on the area of the installation. If we look to our surrounding, the valve is everywhere in the dam that we use to collect the water and transform the flow to be an electricity, or in the car engine that regulate the fuel consumption, either in the shower room that we use today or even just a bottle of water that we drink. Let's move to where is the valve in our heart. Now the duty of the heart is to respond for pumping the blood to the whole body in every second. There are four main types of the valve in the human body that regulate by the heart muscle to control the flow. First, the tricuspid valve that locate between the right atrium and right ventricle, which compose of three leaflets. Next is a pulmonary valve that locate between the right ventricle and pulmonary artery. Then the bicuspid valve that locate between the left atrium and left ventricle. And lastly, aortic valve placed on the left ventricle and aorta. And why, what does the valve do? The main duty of the valve is to control the direction of the blood flow and regulate the duration of the valve open and close to be performed at the same time as the heart beating. Next, let's move to who need the valve. First, begin with those who has a regurgitation or leakage of the valve. The valve is not completely closed, causing a backward flow of the blood. Or this result in the blood back into the atrium from the ventricle in case of a mitral or tricuspid valve, or the leakage of the blood back into the ventricle in case of the aortic and pulmonary valve. Next, with those who has a stenosis or the narrowing down of the valve, the valve opening become like narrow and valve become like or damaged or be stiff. This inhibit the flow of the blood into the ventricle or atrial. The heart is have to apply more force to pump the blood with increasing the force to move the blood to the valve with a narrow and steep pathway. Move to the timeline. It began in 1952. There was the first clinical cases that are performed a cardiac valve implantation, followed by introduction of the case disc valve in 1960 and bulkhead in 1962. Moved to 1970, further introduction of the tilting disc valve and porcine xenograph that gathered the heart valve from the pig and implanted in the patient body was introduced. A further development with the well-known Medtronic Hall tilting disc in 1977 and the first development of the bileaflet valve, followed by the xenograph from pericardium valve to create the heart valve in 1980. Moved to a bit closer to beginning of the 1990, there was the introduction of the stainless mitral valve, and in late 90s, FDA approved the stainless bioprosthetic aortic valve. After for a long journey of the heart valve, it can be concluded that there are like three main type of the artificial heart valve. First is a mechanical heart valve that make from like strong and durable material, which suited for long-term use or valve. However, the patient, those who have or implant this require further continuous consumption of the anticoagulation drug. Next, bioprosthetic heart valve that may from animal valve or part of the animal tissue or with a strong and flexible material. The lifetime of this type is approximately allow like 10 to 15 years with, without the need of the anti-coagulation drug during the implant or after the implant. Lastly, the tissue engineering valve basically is a what in vitro process that using a human cell put into the graft or the scaffold or that have the same shape as the heart valve, which can like improve the further enhance the further treatment outcome. Next, let's move to the mechanical heart valve. It's made from a material that do not include from any like biological tissue. It's made from material that are like strong and have high durability, like carbon coated disc, cellulite, or polymer like PTFE, polyester, or silicone. Normally, it's have a lifetime use, mostly up to like more than 25 year or more, and that's why like for those patients who are still in the young adult, doctor recommend to use this kind of valve in their treatment. However, the thrombus and embolism could like occur during the valve processing due to the material and state that could occur during the performing. So the patient required to intake a anticoagulation drug or to prevent their vascular health issue. And there is also a valve opening sound, like clicking sound from the hitting of the structure during the beating of the heart. Are these are the four type of the mechanical valve that provide today. Our first one is a bulkhead, that is the housing of the metal case and the elastomer ball to block the flow. Next is the tilting disc, which is a outer material ring that are holding the single swing or check valve in the middle. Third is a bi-leaflet valve that have like two semicircular leaflet to control the blood flow. And finally is the tri-leaflet valve that has a three pieces of the leaflet in the middle. First, let's begin with the cage ball type. It composed of like suture ring and metal cage and the elastomer ball to in the center to block the blood flow. The flow emerging from the valve from a circumferential jet that like separate from the ball and push the ball forward, but it's still like stop at the end of the cage and not moving forward. For this type of valve, it has a high shear state exiting at the edge of the forward flow jet and the recirculation region, also with the peripheral leakage that could occur during the backward flow. So they activate the pellet, cause the anti-coagulation, cause the coagulation. Next, move the tuning disc. This composed of a single disc that control a flow by a metal stud. It's control major and minor orifice flow. During the valve open with a different velocity, the disc tilt to form a major orifice and minor orifice for the blood flow. Different with a different velocity of the magnitude that could like induce the recirculation of the blood flow. During the closing, sometime for some design, there is a hole in the center of the disc that causing the peripheral leakage or with the high shear states, which can cause the blood cell damage and lead to the formation of the coagulation too. For the third type, bi-leaflet mechanical valve consists of two leaflets that are like semicircular and rotate allow the start attached to the metal housing provide like more natural of the blood flow than the previous type. Or during the forward flow of the valve, there are three regions of the flow, two lateral of orifice and the central orifice that form a velocity or the velocity in the lateral is like higher than the central. So this form like two recirculation of the region or in the sinus lesion in the aortic root. Or during the reverse flow on the hinge area within the center, there is a most area that occur the butt cut in the center. Next, for three leaflet, while the title and valve, there's a three leaflet allow the flow in the center area and similar to the tricuspid valve of the body that we use today, that we have today. The natural fold of the bud is like significantly showed in the result. It generates like the central orifice jet with a high velocity compared to the other that have average oil allow like to like 2.2 meter per second. However, there is still like a leakage from the backward flow in the center of a leaflet, which can lead to the further bud cut formation due to the high shear stress. Move to other type of the artificial heart valve, a bioprosthetic heart valve, or is generally made from the animal valve or tissue, mounted on a plastic, metal, or polymer housing. Or this functions similarly to the natural physiology of the heart valve, but approximately allow like 50% of the valve fail within the 15 years of the implantation due to the structural breakdown. So this kind of valve will be suited for those who are like older than 60 years. This kind of will not require any like further prolonged intake of the anticoagulation drug after the implant. However, there are like also a limitation for some cases that might uh, cause a rejection, mineralization, or calcification after the implantation and lead to the further failure of the implant. There are two main types of the bioprosthetic heart valve. First one is the porcine valve, which have it from the pig, and the size of the valve is like measured and collect from the pig heart and placed in the metal or plastic material. Next is a bovine pericardium, as the heart valve of the cow is like too big for the human heart. There is a idea of using the pericardium that have it and make it as a main material to create a heart valve by performing a structure with a housing and suture structure for allowing the implant. Lastly, the type of the artificial heart valve. The last type of the artificial heart valve are the tissue engineered heart valve. Is used a human cell to culture on the scaffold, either the biological or synthetic material to enhance the exception from the body or biocompatibility. Begin with the biological scaffold, or this could perform like allograft or xenograft valve, then this decellularize it and or the structure to create a bank scaffold for the cell to stay. Also, other biodegradable like fibrine from the patient, but or the collagen in the form of gel, foam, or sponge. Are next for the synthesis scaffold. There is heading for the polyester group like a polyglycolic acid or PGA or polylactic acid like PLA, and combination of those PGA and PLA provide a better like mechanic property. But there are also like a major limitation of the polyester group that they are like thickness and initial stiffness that are difficult to like form a tight leaflet structure in the complexity of the heart valve structure. And this is my reference. Thank you for your listening.